Hey, hello everyone. So I want to talk about an example today, solving logarithm equations with an example to be exact. Alright, so of all the previous rules that we've talked about solving log equations, so you've got the power property of logs, the quotient property, the product property, changing it to exponentials and anything. So today I want to do an example with all or most of the properties that we've talked about. It's actually rather fun, but anyways. Alright, so we've got, so let's solve for x for the following equation that they give us. We have 4 log base 2 of x minus log base 2 of 5 is equal to log base 2 of 125. Okay, well, first things first, on the left hand side, see, I've got an x here, but I have a 5 here. Okay, even though I have the same base, but my goal is to get x by itself because I'm trying to solve for x. Alright, so I will look at the right hand side first. The right hand side, what do I have? On the right hand side of log base 2 of 125, well, I know 125 is 5 cubed. Alright, so 5 cubed is equal to 125. So I can go ahead and change that. So this now becomes log base 2 of 5 cubed. And by the power property of logs, I can bring the 3 outside. So when I bring the 3 outside, it's going to be log base, oh, I'm going too fast. Alright, just for the sake of neatness, let me erase this arrow over here. So I can bring the power outside, so it's log base 2 of 5. Okay, so this is my right hand side. Now let's put the whole equation together. So 4 log base 2 of x minus log base 2 of 5. This is equal to 3 log base 2 of 5 after our simplification for the right hand side. Alright, so now let's look at the left hand side and the right hand side together. Well, I can take the log base 2 of 5. See, I can observe over here. I have a log base 2 of 5 on the left hand side and I have a log base 2 of 5 on the right hand side. So what I can do is I can move this log base 2 of 5 to the right hand side. Alright, so what you do to one side, you do to the other side. So when I do that, now my right hand side looks like log base 3 log base 2 of 5 plus log base 2 of 5. And then I just bring down what I've had before, which was 4 log base 2 of x. So now this is what it looks like. 4 log base 2 of x is equal to 3 log base 2 of 5 plus log base 2 of 5. Now look here. I have a log base 2 of 5 and I have a log base 2 of 5 on, they're being added together. So you can think of log base 2 of 5 as an x. Alright, you can think of it as an x or a b or whatever variable you want to call it. Because they are the same thing, alright, so you can actually go ahead and add it. So this is actually the same thing as 3x plus x. So it's the same thing as combining like terms as you would for Algebra 1. Alright, so this is just a side note. Or you can like pretend. Okay, so what I can do is, so 3x plus x, that's going to equal 4x. So I have 4 log base 2 of 5. And then I can finally bring the left-hand side down just as it is, log base 2 of x. And then, again, my goal is to get x by itself. So I want to divide out the 4 on this side, on the left-hand side. And what I do to one side, I do to the other side because equations are all about the balance. Alright, so the 4 actually goes away on both sides. And then we are left with log base 2 of x is equal to log base 2 of 5. And by the logarithm rule, if you have the same base on both sides, and in this case we have log base 2 here, and we also have log base 2 here, then you can take whatever is inside the log and set them equal to each other. So finally, what's inside the log on my left hand side is just x, what's on the log of my right hand side is 5. And we have solved for x. X is equal to 5. And then finally we can go ahead and check real quick. Okay, so if I check real quick, does it match? So I have 4 log base 2 of 5 minus log base 2 of 5. Does it equal log base 2 of 125? Okay, and this is the same thing as saying 3 log base 2 of 5, applying the same rules as I did up there, is equal to log base 2 of 125. And we know that that is equal to 3 log base 2 of 5, right? Because this 125 is basically 5 cubes, and we can see that they indeed do match out. Basically, what we're checking for is to make sure that both sides are equal, and you usually don't want to find a negative on one side and then a positive on one side. So since they do match out when we check them, it is true that x is equal to 5.